danger. IntelliRupter PulseCloser fault interrupters operate at high voltage. Failure to observe these precautions will result in serious personal injury or death. Some of these precautions may differ from your company's operating procedures and rules. Where a discrepancy exists, follow your company's operating procedures and rules. This video is intended to be used in conjunction with the written instructions that came with your product, S&C Instruction Sheet 766-530. This video series covers protection and communication setup of an IntelliRupter PulseCloser fault interrupter by using IntelliLink setup software. Before beginning, read and understand the overview section of the written instructions. You will need to be familiar with the unique features and functions of an IntelliRupter PulseCloser fault interrupter before continuing. In this video, we'll configure a general profile. In addition to IntelliLink setup software, software for S&C's Coordinate, the S&C Protection and Coordination Assistant, can be used to configure the curves along with a visual curve display, and can even save curve settings to later upload to an IntelliRupter PulseCloser fault interrupter control. This software can be found by searching Coordinate at snc.com. To get started with a general profile, open IntelliLink setup software and log in. See the previous video in this series for more information on getting started with the software. The IntelliRupter PulseCloser fault interrupter control has 4 general protection profiles that allow for 4 separate protection configurations. Profiles are configured in the Setup Protection tree. From there, select the profile you wish to configure. In this case, we'll select General Protection Profile 1. The screen opens with the Direction 1 Initial Trip profile configuration. There are 4 tabs that need to be configured: Direction 1 Current, Direction 2 Current, Testing after Initial Trip, and Voltage, Frequency, and Sectionalizing. We'll start with Direction 1 Current. If fault testing is not going to be used, Initial Trip is all that needs to be configured. Profile labels can be changed at the top of the Initial Trip screen. Once changed and applied, the new labels will be visible on the operation screen. To configure General Profile 1, start by selecting the elements to be enabled by using the checkboxes next to each element: Phase, Ground, Negative Sequence, Sensitive Earth, and High Current Lockout. Phase is the conventional phase overcurrent element. An inverse segment can be selected and configured with these settings. To configure inverse segment, click on the Inverse Segment box. Different curves have been installed with the IntelliRupter fault interrupter software. They can be found at Users, Public, Public Documents, S&C Electric, Curve Library. In this case, we'll select Base TCC curves, IEEE curves, and the Extremely Inverse curve. Once selected, the curve will populate values for the inverse segment modifications. These can be changed according to your company's protection policy. Changes are held in a memory scratchpad and do not go into effect until they have been applied. The best practice is to validate your changes every 2 or 3 setting changes and apply the validated changes frequently. The general profile also has the option to configure 1 or 2 definite time segments to modify the high current reaction of the inverse segment. This will allow us to create a step curve. Definite time can be set by clicking in the box and entering a value, or selecting NA to disable the definite time element. To achieve an instantaneous trip at a high current level, set the minimum trip time to 0. See S&C Information Bulletin 766-211 for details on the total clearing and minimum response times of the IntelliRupter fault interrupter. Additional elements, such as ground, can be added by using the checkboxes next to each item. Any of these elements can be configured for definite time only. If an inverse segment is not required, elements with a default setting of None do not have to be changed. To configure an element previously configured with an inverse segment to one without an inverse segment, click in the Inverse segment open the Curve Library folder, Basic Curves, and select the No Curve segment. To configure the Direction to current, click the Direction to Current tab. The Copy From button can be used to copy settings from Direction 1 and apply them to Direction 2. Changes to the direction configuration can then be made. When a device is located close to a substation where high currents are possible, protection practices may require that circuit testing not be used. In these cases, high current lockout can be set. This is the current level at which circuit testing would be skipped and the device would go straight to lockout. Remember to keep changes minimal between using the Validate and Apply buttons. It's easier to troubleshoot with minimal changes. With both Direction 1 and 2 validated and applied, circuit testing can be configured. Click on the Testing After Initial Trip tab. This screen is used to configure up to 4 tests after an initial trip. In this example, we will only have 3 tests. Clicking the Add Test button adds a new test. The Remove Test button will remove the last test. For each test and the initial trip, there is the option to do 3-phase or single-phase tripping. This can be selected from the Initial Trip drop-down menu. In this example, we'll use a single-phase trip for the initial trip and 3-phase tripping for each test. Delay in seconds is the delay for each test. As tests are added, the minimum delay in the range becomes longer. In this example, we'll set the delay for test 1 to 0.18 seconds, which will allow the device to trip on a single-phase basis and retest 180 milliseconds after the initial trip. If the fault is still present, it will trip on a 3-phase basis and continue on to a 3-phase lockout. Lockout will use the trip setting of the final test. In this case, a 3-phase lockout. The other parameters for each test are overcurrent sequence and Intelligent Fuse Savings, or IFS, sequence. The IFS sequence is covered in another video. Overcurrent sequence gives the option to do a point-on-wave close, which is labeled Close or a test using pulse closing technology. The default is set to use pulse closing technology. If a fuse-saving scheme is being used, at least one point-on-wave will be needed to allow the fuse to blow for permanent faults. In this case, we will choose pulse close technology for all 3 tests. Below are additional test settings. Overcurrent and IFS source reset time is the time at which the device must be closed and quiet, meaning that no protection elements are picked up, for the test sequence to be considered complete. 3-phase trip for multiple phase faults, when enabled, will allow a single-phase trip to use a 3-phase trip. Retain source side for test sequence should only be used for loop restoration. We cover loop restoration in another video. In all cases where loop restoration is not being used, set this value to No. In the case of a single-phase initial trip, the single-phase current restraint phase and single-phase current restraint ground settings can be configured. When enabled, any current at or above the set value will force a 3-phase trip instead of a single-phase trip. This can be set for either the phase or ground element. Sensitive earth fault tests can also be added and removed using these buttons. Only delay time can be changed for these tests. Once the tests are enabled, time current characteristic, or TCC, curves can be set. In a fuse-saving scheme, it might be valuable to coordinate TCC curves with up- or downstream reclosers. To begin, navigate to the general profile being configured and select the drop-down menu item for TCCs for coordination. There are different options available for the close and pulse operations. Both can use previous or new TCCs. There's also a Copy From button, which will copy settings from the initial trip or another test and paste them into this test. Settings can then be modified to fulfill the purpose of each test. By default, the coordination mode is set to None. In this case, we'll change the mode to Sequence. Coordination Enhanced mode is covered in another video. Coordination reset time is the time by which the sequence coordination curves will be held as the active coordination curves until the elements have stopped timing. The rest of the TCCs for coordination screen is set up the same as the previous tests. The final screen in configuring a general profile is a voltage, frequency, and sectionalizing screen, which can be found at this tab. This screen contains options for voltage trip, frequency trip, and sectionalizing trip. Most voltage functions in the voltage trip section contain an IntelliTeam SG and loops only option in addition to the Yes option. The IntelliTeam SG and loops only options are discussed in another video. Selecting Yes for a voltage function shows the available options for that function. As an example, selecting Yes for the open source sectionalizing function shows the 5 setting options for that function. The open source sectionalizing function is a 3-phase voltage function using positive sequence voltage. The open source voltage threshold is a voltage level at which the function picks up and begins timing. The naming convention is function name voltage threshold for the pickup level of each function. The open source current restraint threshold determines the level of current at which the open source function is blocked. If the current is at or above this level, the function will not trip. If the function has a current restraint, the naming convention will be function name current restraint threshold. The open source reset voltage threshold is the voltage level at which the function will begin resetting. This sets up a hysteresis band that avoids the function from starting and stopping when the voltage levels are changing between voltage threshold and the reset voltage threshold. If the function has a reset level, the naming convention is function name and reset voltage threshold. The open source time to trip is the time the voltage must be above the voltage threshold and below the reset threshold. The open source reset time is the time the voltage must be above the reset voltage threshold for the function to reset. To configure the single-phase protection and sectionalizing, select Yes. This function has the option to use zero sequence and negative sequence functions to detect a single-phase voltage loss event. It contains separate voltage thresholds and a current restraint for zero and negative sequence detection. However, the unbalanced time to trip is common to both voltage detection functions. Similarly, the unbalanced reset time is also common to both. The good source indication is the level at which the voltage source is considered good for IntelliTeam SG automatic restoration system, loop restoration, and circuit testing. IntelliTeam SG system software and loop restoration are topics in another video. After an initial trip initiates a test sequence, any subsequent reclose or operation using pulse closing technology in the test sequence will require the good source indication to indicate good before the test is allowed to be executed. The good source voltage indication is the percentage of positive sequence voltage that the voltage must be at or above for the duration of the good source time to detect time for the indication to be considered good. The low source voltage threshold is the percentage of positive sequence voltage that the voltage must be below for the time to detect low voltage duration for the indication to change to low or bad. Again, the difference between the good source voltage indication and the low source voltage threshold sets up a hysteresis band that avoids the indication function from toggling between good and low when the voltage levels are changing. Selecting Yes for the trip on single-phase voltage shows it has high and low voltage thresholds. These thresholds are set as a percentage of the nominal line-to-ground RMS voltage. The function will use the lowest and highest phase voltage magnitude in its response. Current supervision for this function is optional. Select Yes for the current supervised on low voltage to prevent tripping when the voltage is below the low voltage threshold. there are separate time-to-trip times and reset times for the low and high thresholds. The low single-phase alert is a binary indication threshold that sets and resets a DNP status point when one phase crosses the voltage threshold. See S&C Instruction Sheet 766-560 for more information on the IntelliRupter Fault Interrupter's DNP implementation. Selecting Yes for the trip on three-phase voltage shows it has high and low voltage thresholds. These thresholds are set as a percentage of the nominal line-to-ground RMS voltage. The function will time up or down when all three phases are above or below the threshold settings. Select Yes for the current supervised on low voltage to prevent tripping when the voltage is below the low voltage threshold. There are separate time-to-trip times and reset times for the low and high thresholds. The low three-phase alert is a binary indication threshold that sets and resets a DNP status point when all three phases cross the voltage threshold. See S&C Instruction Sheet 766-560 for more information on the IntelliRupter Fault Interrupter's DNP implementation. IntelliRupter PulseCloser fault interrupters have the ability to configure under-frequency and over-frequency thresholds. When enabled, the device will trip after it exceeds either level for the configured frequency time-to-trip timers. Both elements are trip to lockout. Additional low-frequency elements are available with IntelliTeam SG Systems software and loop restoration. If the device is used as a sectionalizer, the sectionalizing trip elements can be configured. This is typically done in IntelliTeam SG systems, but can also be done as a general practice. Selecting Yes for the fault current detected, counts to trip function enables sectionalizing on fault counts. Counts to trip sets the number of fault current and voltage loss events that must be counted for tripping. The voltage loss association time is the time between the end of an overcurrent event and the start of the three-phase voltage loss. If the voltage return is shorter than the voltage loss association time, the current voltage loss event will not be counted. Phase fault and ground fault minimum current settings are the levels the fault current must be at or above for the phase fault and ground fault definite time durations for the current voltage loss event to be counted. Selecting Yes for the loss of voltage only functions enables tripping on voltage loss counts. Counts to trip determines the number of voltage loss events for tripping. The open source voltage threshold determines the percentage of line-to-ground RMS voltage the voltage must be at or below to be counted as a voltage loss. The reset time is the time the voltage must be above the open source voltage threshold to be qualified as a return of voltage. This concludes configuration of the general protection profile. All four protections profiles have the same layout and are configured in the same way.